I'm just wondering now what this object is.
This is the cork of the champagne bottle that was opened when I got my PhD. And then my supervisor, there's something about, I think it's lucky if somebody puts a piece of silver into it. So he said to hold on to that forever. And yeah,
And
it's sort of, yeah, I did. And it represents sort of the start of your career. And yeah, the fact that you do need luck.
I think that's brilliant. I've never actually seen the silver. I've seen people saving corks like that, but I've never seen the silver in before. It's lovely, even the old 5p too. And that was, how long ago was that, or should I ask?
That was in the 90s.
Right, okay, brilliant. So that's been sitting, you've kept that for decades.
Yeah.
And will continue to do so. What's this?
That is a jar of coral and shells because I guess I love the sea.
Why do you love the sea, I wonder?
I love the sea because it's strong. I like it because it's calm. I like it because it's fresh.
Do you swim in the sea?
I do in the summer, not in the winter.
In Dublin?
No, I'd swim off Clare. I'd be quite choosy about where I'd swim.
Okay, so it was in the west that you found this?
I think that was that would represent shells and pieces of coral from lots of places, probably Galway, Clare.
And what's this? Was this your first hairdryer?
No, yeah, I guess in science you can use very regular things in research experiments. So we would do a lot of what's called chromatography, thin layer chromatography. So you would be putting pieces of lipids, which are fats, on a silica plate, and you'd want to hurry up the process. So you would dry the samples using your bog standard hairdryer.
Isn't that absolutely gas? And it's amazing to me that these things are sort of physical things, that in science you're not just using things that come out of bottles and all very cleaned up and pared down things. You're physical things that can actually be dried with a hairdryer.
Yeah. So, yeah.
But that's gas. That didn't arrive in the lab yesterday anyway,
No.
that one. And what's this?
That is a biopsy needle.
Right.
So my area is nutrition and sort of food and health. So it's we do these experiments with people and, we might be investigating the impact of whatever ingredient or whatever food, and then we have to measure it in the body. And the only way you can measure it is by taking a sample. So this would be a biopsy needle to take a adipose or a fat biopsy. So it's huge. And that would go into your either thigh if we wanted a skeletal muscle sample, or into your belly or into your butt to get an adipose sample. And then you see there's a little hole there.
Yeah.
So you put it in, you take it out, and then you get a chunk of the tissue that you need. And I guess a lot of volunteers have done a lot of studies for us, have eaten and drank a lot of horrible concoctions and done a lot of very unpleasant procedures like that. And it's only without their help we couldn't do it.
What's your name?
My name is Helen Roche.
And you work in?
I work in the Conway Institute in UCD.
And so this is your area, nutrigenomics?
Nutrigenomics, so it's nutrition and genomics.
Okay. So the only way that you can study that is actually to study how all of that, the end result of all of that in a person.
Mm-hmm. Yeah, because you see, I guess when things started off in nutrition, people thought just about vitamins, maybe just about minerals. But if you think of a food, say you've got that orange, and that orange is much more than vitamin C. There are other elements in it which may be active. And it's the only way you can really understand that is by seeing how it goes into the body, how it gets into the bloodstream, when it goes in from the bloodstream into different organs. We look at the immune system, and you can only do that if you capture the tissue and take the biopsy and measure it and look at the impact.
So it's interesting to me that, actually what you eat in terms of food, orange, apple, can actually have a downstream actual effect on your immune system of all things.
Yeah, and sometimes we investigate the effect of foods per se. Sometimes we select out different elements in foods, not even nutrients. And say, for example, those capsules, they contain a spent brewer's yeast, which we now know is very good at training your immune system. So you see, some people, their immune system is either not as active as it should be, so they're not as resilient to infections, or it may be overactive active and hyperactive, and you don't want that either. So we're trying to figure out contexts wherein you can sort of train your immune system such that it'll respond the way it's supposed to respond, and at the right time and in the right place.
That's amazing. So this spent yeast can actually do that. When you say train your immune system, what do you mean?
It's literally training, as in, it's like the response to physical activity. If you want to run a marathon, you will train for a number of months beforehand so that your muscles are fit, that they're healthy. Similarly, your immune system, you can train it by lots of lifestyle factors, one of which is diet. And the beta-glucans, which are the compounds in the baker's yeast, they train the immune system such that it will be far more responsive in an appropriate way.
Wow.
Because you see, you want your immune system to be off most of the time and then just to switch on when you have an infection. So sometimes people are immunosuppressed, say when you get older. So an older person might need that to bump their immune system up. Or somebody else would be, their immune system would be hyperactive and you want to calm it down and pull it back. So because that hyperactivity is just too on for too long, it can cause damage. So it's trying to understand that balance.
So that's amazing. You're actually able to, so for example, here's a wrapper of a butter. So if I was a person who loved eating butter on my bread every morning, that would, do you actually know how that would affect my immune system?
Yeah, there's nothing wrong with butter in terms of, your immune system, as it were, in moderation. But yeah, every food element will have an impact on it. But it's not going to be down to one food or even several foods. It's going to be how that food interacts with, what age you are, whether you're a man, whether you're a woman, what your family history is, what your genetics are. And it's trying to understand the combination of those elements.
Okay, and that's what
we do, yeah. So a lot of the work, it's in the space of personalised nutrition and personalised health. So you, Lorna, would have certain elements of your body would be healthy, certain elements may be unhealthy, and it's trying to figure out what are your pressure points, what are your sensitivities. And then if you know what you might be predisposed to, then you could proactively sort of mind yourself and, look at different elements of your diet. It
seems like a really kind of sensible and interesting, particularly, obviously everybody now knows, these words, the immune system and the, I'm trying to remember the word for the effect, the immune, in the recent COVID-19 pandemic, the overreaction of the immune system.
The hyper response.
Yeah.
You see, that was the problem, where that was what was wrong, essentially, with some people who just didn't respond well. They responded to the infection, but then their inflammatory system just went into overdrive and it couldn't switch off. So it's trying to understand, what switches it on, which we have a fairly good idea about, but it's the extent to which we can calm that back down again.
It's amazing.
So yeah, it's that inappropriate response and just trying to tweak that.
Yeah. So so the vision maybe would be that sort of down the road people might be able to have more of a direct understanding in their lives or be able to go to an expert who could advise them.
Yeah. But the immune system is very complicated. So there's a lot out there at the moment in terms of public media going, boost your immune system. But being quite honest, we don't have a full picture of how and why and whatever. But we'll get there.